Okay, we're going to be talking about probability. We're going to introduce ourselves to probability. Now we talked about counting methods last week, but now probability. Now a probability, it's a decimal. It's basically percentage given as a decimal. I know, let me draw a little table up here. 0%, so percentages, 0% means that there is not going to happen, right? 0% is for sure not going to happen. 100% for sure that it will happen. So probability is basically the percentage that an event is going to happen. So it's between 0 and 100%. However, probability, we don't write it as a percentage, we write it as a decimal. So it is our percentage written as a decimal. So 0%, the probability that's not going to happen is 0. 100% as a decimal, you learn back in the days that you write that as a 1. So probability is going to be a decimal between 0 and 1. So more than 0, less than 1. So yes, I expect my answer to be 0 point something. Let's say I had like 25%. 25% is closer to 0 than 100. So there's a higher chance that it will not happen. The probability, percentage-wise, is 25%. Probability-wise, we read that as 0.25. Again, probability is as a decimal, percentage given as a decimal. So I expect it to be more than 0 and less than 1. Okay, let's take a look at here. You roll 2 dice and add the results. Okay, how do dice look like? They look like this, right? You have 2 of them. And I could get like a 1, 2, a 3. I could get a 4, a 5, and a 6, right? My choices are from 1 through 6. Let's call each of these. Let's say I have a yellow dice. Oops, let me use my highlighter instead. Let's say one of my dice is yellow. I mean green. Don't know my colors anymore. And then let's say the other dice is yellow. Okay, so one of my dice is green and one of them is yellow. The table here at the bottom, basically all my outcomes. All my green die, I can get from 1 through 6. I can get a 1, 2, 3, 4, or 5, or 6. On the yellow die up here, I can get 1, 2, 3, 4, 5, or 6. The same results, right? I roll my dice. And then in white, in the center, is my results. For example, let's say on the green, I get a 5. And then on the yellow, let's say I get a 3. That's right here, right? 5 green, 3 yellow. If I add my results, I get an 8. So here are all my possible outcomes. If you notice, there's possible outcomes. I can get as low as a 2 if I get a 1 on each of my die, and I can get as high as a 12 if I get a 6 on each of my dice, and then I can get a bunch of numbers in between. So now here, my question here is, what's the probability that I get a 5? So what I'm going to do, let me write this as a fraction first. On the top of my fraction, I'm gonna write how many times it happens. So probability I get a 5. Let me circle all my 5s. How many 5s? How many ways I can get a 5? And I'm gonna say 4 times. Okay. At the bottom, how many possibilities are out there? How many are all the possible outcomes? There's 36 of them. If you see how many white squares I have 36. How many possible results? So I have 4 out of 36. Now, I said probability is given as a decimal, and I have it as a fraction. So what I'm going to do, I'm going to go 4 divided by 36. According to my calculator, because I'm going to use a calculator in my case, I get a 0 point and a bunch of ones. We're in statistics. This is stats class. I don't need to remind you guys how to round. But let's say I'm asking to round it to the nearest hundredth. Okay, 100 sounds like a 100, which is a 1 with 2 zeros. So I expect it to be 2 decimal places. My answer would be 0.11. I expected my probability answer to be a number, a decimal number between 0 and 1. So more than 0, less than 1. So 0.11 sounds about right. Let's take a look at number 16. You have a spinner with 5 reds, 3 blues, 3 green, and 1 yellow. If you look at the spinner, that is what we have. And then you also have a fair coin. Okay, so on the coin, I either get heads or tails, right? And we're gonna call it fair because that means that it has the equal chance of landing on heads as it does in tails. Now here, I'm asking for what's the probability of RH. So we have to understand how to read probability. On the first thing is the spinner. So I'm asking what's the probability that I get red on the spinner, and the H means I get heads on the coin. So let me take a look at each of the probabilities. What's the probability that I get red, and what's the probability that I get heads? So I'm gonna look at each of my probabilities. Now on the spinner, what's the probability that we get red? How many reds are there? 5 reds. How many spaces are there all together? There's 12 of them. So probability I get red, it's 5 out of 12. What's the probability I get heads on the coin? How many heads are there? 1. How many possible outcomes are there? 2. Because I want this both to happen, I'm gonna multiply my fractions. Now multiplication of fraction was not that hard. Let me multiply the top. 5 times 1 is 5. Let me multiply the bottom. 12 times 2 is 24. So probability that I get a red and I get heads, it's 5 out of 24. So I'm gonna grab my calculator. I'm gonna go 5 divided by 24. It gives me 0.208 and a bunch of 3s. Let me round this again to the nearest hundredth. Let's say this one says round it to the nearest hundredth. So I look at the third decimal place. It is big enough. So my answer is 0.21. Might seem simple. Yeah, we're introducing to probability. So it's not that bad. An experiment results in one of the sample points, E1, E2, E3, E4, or E5. Okay, so I'm gonna do an experiment, and my results are either E1, E2, E3, E4, E5. I get one of these 5 choices. So when I read this, it says find probability to E3. So PE3 says find the probability of E3. Because it says find, right here for E3, let me write X. I don't know what E3 is, okay? If probability of E1 is 0.2, so the probability that lands on E1 is 0.2. Probability that it lands on E2 is 0.3. Probability that it lands on E4 is 0.2. And probability that lands on 5 is 0.1. Now, one thing on probabilities, when I add all my possible outcomes, when I add all my probabilities, all my possible things, I get 1. Really, Mr. Leonzo? Yeah, go back over here. How many, if I roll 2 dice, how many possible outcomes can I get? Add them all up. There's 36 of them, right? Out of 36, so isn't that 1? Yeah, all the probabilities combined is 1. So here, let me add all of these. So I have this as 0.2 plus 0.3 plus X plus 0.2 plus 0.1. All of them is equal to 1. Again, when I add all my probabilities, has to equal to 1. The rest looks like just like a simple algebra question. Let me separate them through the equal sign. When it comes to variables, I just have 1x. When it comes to decimals, 0.2 plus 0.3 plus 0.2 plus 0.1. Add them all up, and that gives you 0.8. And all of this is equal to 1. So I have that x plus 0.8 is equal to 1. Remember how your previous teachers used to say isolate the variable? Basically, then the decimal, get rid of it. So this 0.8, let me write it on the other side as a minus 0.8. Notice how I switched the sign, right? Don't forget that. So I'm going to say that x is equal to 0.2 because 1 minus 0.8, isn't that 0.2? Now when you're answered, because I'm asking for the probability, I'm just expecting the decimal 0.2. Nice. Let's take a look at number 18 now. The instructions are the same. When I do my experiment, I can either get E1, E2, E3, E4, or E5. So let's take a look at all of them. It says find the probability that I get E3. I don't know what E3 is, so let me put an X. If probability of E1 is equal to probability of E3. Okay, so that's important. I don't know what E3 is. So I don't know what the probability that E1 is. However, they're equal. So I'm going to call it X as well. I'm going to use the same letter because they're equal. So I'm going to use the same letter. Probability that I get E2 is 0.2. Probability that I get E4 is 0.1. Probability that I get E5 is 0.1. And I know that when I add all my probabilities, so if I go X plus 0.2 plus X plus 0.1 plus 0.1, if I add all my probabilities, I get 1. All right, the rest looks like a simple algebra question. When I combine my variables, 1x plus 1x, I usually call that 2x. When it comes to decimals, 0.2 plus 0.1 plus 0.1, I usually call that 0.4. And this is all equal to 1. So this plus 0.4, let me move it to the other side as a minus 0.4. Don't forget to switch the sign. So I get that 2x is equal to 0.6. So to solve for x, let me divide by 2, and I get that x is equal to 0.3. Okay, so what does x mean? Probability that E3 is 0.3. Probability that I get E1 is 0.3. My question was, find the probability that we get E3. Oof, that was not that bad. Let's take a look at 19 and 20. The sample space for an experiment contains 5 sample points with probabilities as shown in the table. Find the probability of each of the following events. So let's take a look at number 19. I'm asking, what's the probability that I get PA? So I get 5 possible points. 1, 2, 3, 4, 5, right? I'm looking at my sample points. The probability that I get a 1 is 0.05. The probability I get a 2 is 0.18. The probability to get a 3 is 0.26, so on and so forth. Okay, so we know how to read this table. I'm asking probability of A. So I'm looking at A here. Either 1, 3, or 4 occurs. So I either get 1, 3, or 4. The word or, very important. It basically means plus. The probability I get a 1 is 0.05. Plus, probability I get a 3 is 0.26. Probability to get a 4 is 0.29. The probability, when I use the word or, again, I'm just going to add them up. 0.05 plus 0.26 plus 0.29, it gives me 0.60. Some of you might be like, what if I write that as 0.6? Well, either one. Isn't that the same thing? 0.60 or 0.6? As you wish. Okay, it's the same number anyway, so as you wish. Let's take a look at number 20. Probability of B. Either 1, 3, or 5 occurs. So 1, 3, or 5. Because I'm using the word ORed, I'm going to add them all up. So I'm looking at 0.03 plus 0.26 plus 0.25. Use a calculator if you need to. Now this one I get 0.54. Now one of you might say, well, can I write this as 0.5? No, in this case, 0.54. All right, so today I'm working up into question number 22. So let me flip the page. Let me flip the page for the last questions of today. Make sure you read the instructions on each of your questions. I'm going to have the same instructions for both of my examples, for 21 and 22, but not on your homework. I'm going to change the instructions on each of your homework questions. So make sure you read that. Originally, one brand of chocolate candies came in only a brown colored. Today, this chocolate candies come in 6 colors: brown, yellow, red, blue, orange, and green. Okay, so far what I read is there's candy that comes in different colors. Originally it was just brown, but now it comes in 6 different colors. According to the company, today, 27% of all its chocolate candies produced are blue. 20% are orange, 16% are green, 15% are yellow, 14% are brown, and 8% are red. So I see the percentages for all the different candies. Suppose you purchase a randomly selected bag of these chocolate candies and randomly select one of the candies from the bag. Number 21, it says, what is the probability that the selected candy is brown, which is the original color? So I'm looking at the question here. It is, what's the probability of brown? Okay, so according to the instructions, brown is 14%. And if your homework, you go in, type in 14, it's going to say this is wrong. Remember, I said probability is percentage written as a decimal. So 14% is going to be 0.14. In reality, percent means for every 100. So I have to go 14 divided by 100, and that's how I get 0.14. I said probability is a decimal between 0 and 1. So 14, for sure, is not it. Good. Let's take a look at number 22. What is the probability of selected candy is either red, green, or yellow? Okay. Remember the word or, I have to add them up. So I have to look at what's the probability that I get red? What's the probability that I get green? What's the probability that I get yellow? But I'm going to add them all up because I'm using the word or. Okay, what's the probability that we get red? According to my instructions here, 8%. What's the probability that we get green? 16%. What's the probability that we get yellow? 15%, right? I look for that in my instructions. When I add all of these, this gives me 39%. But again, if I type in my answer 39, it says it's wrong. I expect probability to be a number between 0 and 1. So 39% basically means 39 divided by 100. So 0.39. And zoom out so you guys can see what we did.